Welcome to our video. Today we're diving into the Amazon Virtual Private Cloud Connectivity Options white paper. In this video, I'll walk you through the key points in this document because I feel that understanding these VPC connectivity options is essential for anyone preparing for the AWS Solution Architect Associate (SAA) exam. If you think that you need more info, please read the white paper at the description. Let's start with connecting your on-premises network to an Amazon VPC. AWS offers several options to extend your internal network into the AWS cloud. Amazon VPC provides the option of creating an IPsec VPN connection between your remote networks and Amazon VPC over the internet. For the site-to-site VPN setup, you'll need a virtual private gateway (VGW) for your AWS VPC to serve as the AWS side endpoint. You'll also need a customer gateway representing your on-premises gateway device, such as a router or firewall, which will connect to AWS. Next, configure the site-to-site VPN connection to establish the secure tunnel between your virtual private gateway and customer gateway. This setup creates a managed IPsec VPN connection over the internet, but since it relies on the public internet, latency and availability may fluctuate. The site-to-site VPN supports both static routes and dynamic border gateway protocol (BGP), allowing for flexible routing options. Direct Connect provides a dedicated, private connection between your on-premises data center and AWS, ensuring a reliable path without using the internet. You'll need to locate an AWS Direct Connect location, which includes a Direct Connect router and a customer router. In your on-premises data center, you need to set up a customer gateway, such as a router or firewall, to connect to the customer router. For AWS resources, you'll first need to set up a virtual interface (VIF) to enable Direct Connect to access your AWS resources. Then configure a virtual private gateway (VGW) for your VPC to handle the AWS side connection. For high-performance, stable connections, AWS Direct Connect offers a private, dedicated link bypassing the public internet, resulting in lower latency and improved security. This solution is ideal for high-throughput applications or those with stringent performance requirements. There are several designs that integrate Direct Connect with Transit Gateway and site-to-site VPN for increased reliability and security. If you need a central hub for multiple VPCs, consider AWS Transit Gateway with either site-to-site VPN or Direct Connect. AWS Transit Gateway also is a service that helps you simplify and manage connections between multiple VPCs in AWS using a hub-and-spoke design. Instead of each VPC needing direct connections to all others, each VPC just connects to the Transit Gateway, which then routes traffic to other VPCs. This setup works for both IPv4 and IPv6 traffic. Transit Gateway allows you to connect multiple networks and VPCs efficiently, managing all traffic through a single, scalable hub. Now let's look at Amazon VPC to VPC connectivity options, allowing seamless communication between VPCs in the same or different regions. VPC Peering connects two VPCs for private communication using AWS's backbone network. Amazon VPCs do not support transitive peering, meaning that two VPCs cannot communicate through a third VPC. Each VPC must have a direct peering connection with any other VPC it needs to communicate with. If you need multiple VPCs to communicate with each other, you will have to create individual one-to-one VPC peering connections between them. Alternatively, you can use AWS Transit Gateway as a network transit hub to simplify this communication. Let's move on to AWS PrivateLink. Before AWS PrivateLink was available, services within a single Amazon VPC could connect to multiple VPCs in two main ways: using public IP addresses via each VPC's Internet Gateway, which had security and exposure drawbacks, using private IP addresses with VPC Peering, which required complex configurations and didn't support transitive routing across VPCs. With AWS PrivateLink, you can establish secure, scalable, and private TCP connectivity from the service provider's VPC to consumer VPCs, keeping traffic entirely within the AWS network. AWS PrivateLink supports connectivity to specific AWS services, services hosted by other AWS accounts known as endpoint services, and supported partner services in the AWS marketplace, all via private IP addresses within your VPC. To use PrivateLink, first identify the service you want to access. It could be an AWS service, such as an API endpoint, or a service hosted in another VPC, or even another AWS account. The service you're connecting to must have a Network Load Balancer (NLB), as PrivateLink relies on the NLB to route traffic. If you want to privately connect to AWS services or custom VPC endpoint services, you can use a VPC endpoint. There are two types of VPC endpoints: interface endpoints, gateway. Endpoints, a gateway endpoint, targets specific IP routes in a VPC's route table, represented by a prefix list, to privately route traffic to services like Amazon S3 and DynamoDB. Gateway endpoints do not use AWS PrivateLink. Therefore, if your VPC needs private connectivity to S3 or DynamoDB, you should configure a gateway endpoint. On the other hand, interface endpoints enable connectivity to services using AWS PrivateLink. An interface endpoint is a collection of one or more elastic network interfaces, ENIs, with private IP addresses that act as entry points for traffic destined for supported services. Finally, I created this decision tree for myself to remember the options, so hope that helps you as well. Thank you for watching. Please make sure to subscribe to support me. For more details, refer to the AWS VPC Connectivity Options whitepaper.